I'm Kevin Wallace, and I will be touching on Newton's laws of motion. Also, throughout this video, I will touch on forces, weight, and friction. Let's go. Alright, first things first, key vocab and formulas. We want to touch on this before we touch on Newton's laws of motion. Force. The definition for force is a push or pull on an object. The formula for force is force equals mass times acceleration. Next, mass. The definition of mass is the amount of substance in an object. The formula for mass will be mass is equal to force divided by acceleration. Acceleration. The definition for acceleration would be the rate and change of velocity of an object. The formula will be acceleration equals force divided by mass. Last but not least, weight. Weight is the amount of force on an object due to gravity. The formula for force would be weight is equal to mass times acceleration due to gravity. Welcome back. Now it is time for us to touch on Newton's laws of motion. The first law states, an object in motion will stay in motion unless an unbalanced force acts upon it. This means, if an object is moving, the object will continue moving in a closed environment until an opposite force acts on it, stopping its movement. On the flip side, an object at rest will stay at rest unless an unbalanced force acts on it. So if an object is still, it will remain still until you push it with an unbalanced force. This law connects to the law of inertia. The law of inertia states that the law of inertia is an object has a tendency to remain at its state in motion. So an object at rest wants to stay at rest, and an object in motion wants to continue in motion. On to the second law. The second law states acceleration is produced when a force acts on a mass. This law is called the law of acceleration or motion, mainly because it talks about exactly what is needed for an object to move. Last but not least, the third law. For every action, there is an equal but opposite reaction. That means whatever force you put on an object, the object is putting the same amount of force or a greater amount of force on you. So me standing here on this floor right now, I might be putting 20 newtons of force onto the floor, and the floor is repaying me with 20 newtons, which is keeping me from falling through the ground. The third law connects with the law of conservation. The law of conservation states that the momentum of two objects will remain the same after a collision. Say for instance, a car is driving at 50 miles per hour with a momentum of 50 newtons, and another car is driving at 10 newtons, driving with a momentum of 10 newtons. Once they crash, the second car might pick up speed and might have let's say 35 newtons of force, but the first car will drop its force so that it matches with the second car. Alright, thank you for watching my video. I'm out.